Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your WaveTester Optical Power Meter for proper operation using a WaveSource single-mode light source. Patch cables and test equipment should always be checked prior to testing to ensure accurate and reliable test results. This is usually a good thing to do at the beginning of the testing day. In this procedure, we will be using the WaveTester Optical Power Meter and the single-mode port on a WaveSource optical source. Now you'll see that there are two patch cables used for this procedure. This reference cable will be used to connect the WaveSource into the link under test, as well as zero out the equipment. The second cable is used to connect the WaveTester into the link under test, and this mating sleeve connects both of these cables together for the purpose of checking them to make sure they're working properly. Now, one of the main things that you want to make sure of when selecting patch cables is to ensure that the connector types match, or the connector types are correct. We want to make sure that the one end of the patch cables can connect into the testers, and the other end of the patch cable plugs into the link under test. Now, this is not always the same. We could have SC connectors on our testers, but LC in our patch panels. In that case, we would need a pair of SC to LC cables. In this case, we're just going to assume that the patch panels are SC, so hence the SC to SC cables here. Okay, now the first step is to power on the testers. So we press the power button on both of the units. Okay, and notice that on the WaveSource that we're on the multi-mode port by default when we power it on. So we need to press the port button to switch over to the single mode port. Okay, now that we're done there, we'll return back to the WaveTester and we'll look at the display. We'll see that the word low appears. What this means is that there's no measurable amount of light entering the photodetector. That's because it's covered up with a dust cap. Okay, if we remove the dust cap, we'll see that we get a reading on the screen. In this case, it says around minus 56. Okay, this is normal. What's happening is that since there's no connector plugged in or no dust cap, ambient room light is entering the photodetector, and this is a typical value for ambient room light. So when this happens, don't be alarmed. This is normal. This is what's supposed to happen. Okay, the next thing we want to do is connect in the reference cable into the testers. All right, at this point, I would actually like to demonstrate an interesting feature of the WaveTester and the WaveSource, and that is auto mode. Okay, auto mode allows the tester to test both wavelengths simultaneously, in this case 1310 and 1550. Okay, so in order to set the WaveTester into auto mode, we simply press and hold auto. We'll see that it says AUO here, and we'll see that we have the wavelength indicator and the word auto alternating. What this means is that the WaveTester is in auto mode, but it's not receiving an auto testing signal yet. This is because we haven't set auto mode on the WaveSource. To do that, we simply press and hold the auto button. Watch this indicator LED. The second it begins flashing, we remove our finger. Okay, so we give it a few seconds to go through both wavelengths, and eventually we will see on the WaveTester that we will be switching between 1310 and 1550. Okay, and if you watch this for a few seconds, you'll see that that's happening. All right, what we need to do here is pay attention to the values we're getting for both wavelengths, okay, because this is what's telling us whether the cable's good or not. Okay, our target value is around minus 10 dBm. Now, it could be a little higher or a little lower, depending on how good the patch cable is. But in this case, we're a little bit lower, so minus 10.2 for 1550, minus 10.4 for 1310. Okay, this is normal. This is a good patch cable. What we really want to look for is whether or not we're below minus 11 dBm. If we're below minus 11, there's probably something else wrong with the cable, and it should be replaced. Now, to easily check the loss of this cable, we can temporarily zero out the WaveTester. So we press and hold the zero button here. And what this does is zeroes out both wavelengths simultaneously. Notice we switch to dB mode, and that when it switches for both wavelengths, it says roughly 0 dB. Okay, what this means is we've zeroed out our equipment. That's why we call it 0, because the readings are 0 now. Okay, so once we've zeroed out the this reference cable, what we want to do is disconnect this reference cable here from the detector, and notice we will lose auto mode temporarily and be measuring room light. And this is normal again. This is only temporary until we connect everything back together. But we put the mating sleeve on the end of the reference cable, and then we connect in the one end of the test cable into the mating sleeve, and then finally the other end of the test cable into the detector port again. Okay, now what we're looking for is the wave source to go through a little bit or a couple cycles of auto mode, and now we can see what our loss is between the two wavelengths. Okay, what we're looking for here is a value of no more than minus 0.5 or so. 0.5 is probably fine. So 0.36 here, and for 1310 we see 0.52. That's right on the edge, but it's still okay. The reason we're doing this is to make sure that we're measuring the loss of this cable so that it doesn't so we know that it's not introducing too much loss into the test that we're taking. Okay, what it's actually happening, it's measuring the loss of this cable and this mating sleeve. Now, if we're far below minus 0.5 here, then what we want to do is make sure we either replace this cable, clean it off. Maybe this mating sleeve is wearing out, but if it's good, which it is in this case, we can now be assured that both cables are sufficient for use, and we can continue with our test.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.